Hey everybody! Imagine that you are trying to solve a problem and your solution requires that you find the index of a specific element inside of a list. As it turns out, there's a number of different ways to do this, and you can make your search algorithm quite efficient if you have prior knowledge about the list. Namely, if you know that the list is already sorted, you can use an algorithm known as binary search, and this is our topic for today. So I would say let's get started. Now, before doing anything else, I want to quickly establish a baseline for our development using the naive approach that's known as linear search. This simply means that we iterate over the whole list from left to right, and inside of the loop we compare the loop's current element with the element x that we are looking for, and as soon as the two are equal, we simply return the current index of the loop. This index then corresponds to the first occurrence of x inside of our list, which is exactly what we wanted. If x could not be found in the list, we return -1 to make it absolutely clear to the caller that x is not contained in the list. I'm adding a few assertions as well to ensure that our linear search function is correctly implemented, and also to help us with the implementation of the binary search function, which we are going to start with now. The binary search function has exactly the same signature as the linear search function, with the added requirement that the input list must be sorted. Unfortunately, we cannot express this with type annotations, but we can at least document it. I don't want to copy all of my assertions and change them to use the binary search function. Instead, I'm going to use a little bit of metaprogramming magic. This uses the fact that functions in Python are objects and can be passed around just like any other object. Now, as for the binary search function itself, this function is basically looking at an interval with a lower and the upper boundary, and as the search progresses, this interval gets smaller and smaller and smaller. In the beginning, the interval corresponds to the whole list because we cannot yet make any assumptions where the element we are looking for may be inside of the list. Now, to actually make this happen, we need a while loop that will be running as long as the lower boundary is less than the upper boundary. As soon as the boundaries are the same, the loop can terminate. Inside of the loop, we calculate the element that's exactly in the middle of the current interval, which is the element that we will be using to compare against x. If the element we selected for testing is greater than or equal to x, we know that we can reduce the upper boundary, because the element x that we are looking for must be before the element that we selected for testing. Remember that the input list must be sorted. On the other hand, if the element we selected for testing is less than x, we can increase the lower boundary, because we know at this point that the element we are looking for must come after the element in the list that we selected for testing. In this case, the comparison was less than, and therefore we can add a +1 when we update the lower boundary, because we don't have to look at the element that we just selected for testing again in the next iteration of the algorithm. So last but not least, we have to return the correct result. So after the loop, there should be only a single element left inside of the interval. And if this is the case and this element happens to be equal to x, then we return its index, and otherwise we return -1 because the element could not be found. This special case handling is only needed for the case where you call the binary search function with an empty list. Now, if we run the program, we don't get any output, which means that all of the assertions passed and both our linear and binary search algorithms are correctly implemented. So that's it for today. Thank you very much for watching. I'm happy to answer your questions. If you have any, just leave a comment, and hopefully see you next time. Bye bye.